Welcome to the icsynth retrosynthesis tutorial from Infochem. Infochem's icsynth is a powerful computer-aided synthesis design tool that enables chemists to design new synthetic pathways for target molecules. This video will introduce you to icsynth and show you how to use the retrosynthesis features. icsynth can be accessed via web browsers, and Google Chrome is recommended. All user interactions take place in the web browser, and the business logic of the system is installed on a secure server. After logging in, you will see the home screen with the main commands across here. New Query is for starting a new synthetic analysis. Show Queries allows you to browse and analyze former queries. Show Molecules allows you to browse and edit saved structures and use them in new queries. And Show Strategies is an advanced feature that will be discussed in another tutorial. Along the top are the menus containing additional options and commands. So to start your new query, click here and you are taken to the New Query screen where you can draw your target molecule. A single click in the white box takes you to the structure drawing editor. icsynth provides all the features required to draw structures. We will now input our target molecule. First of all, I will draw a short chain, then add 2 cyclopropane rings, and finally a nitrogen atom. Then click on OK when finished, and the structure is transferred to the target window. You now have the option to give your new query a name. If you decide not to, then the system will automatically allocate a query number, which is the date plus an additional check number. We will call this target molecule dicyclopropylamine. Click on OK and return to the query menu. The default direction is retrosynthesis. Forward reaction prediction for reactivity mapping is the subject of another tutorial. The number of first-level suggestions is set at 10. This controls the number of precursors you see for the target molecule at a given level, or the breadth of the synthesis tree. You can change this to show up to 250 precursors, but we will set this for our query at 20. The number of steps is set at 2, and this refers to the number of steps back in the synthesis or the depth of the synthesis tree. You can change this up to 10 steps, but we will keep this at 2. The default precision is set at medium, but can range from high to low. This controls the size of the structure template in the knowledge base that matches the target molecule. High precision gives only very closely matched templates to your target, so fewer answers may be obtained. Conversely, low precision matches smaller templates with the target, so gives more answers and possibly more noise. We will set this for low for this particular query. The default strategy is given here, and we would recommend that you would use the default strategy. Finally, you need to choose which of the reaction libraries you wish to use. These are at the heart of icsynth, which is an algorithmic chemical knowledge base of transform libraries. They are automatically generated from some well-known published reaction databases. In this case, we will select Cheminform, Sprezzi with 3 or more reaction examples, and name reaction transformations. Having completed our parameters, we can then press Start to begin the query analysis. The system indicates that it's busy and will tell you when the result is ready and the tree is finished. The left-hand menu displays the selected query parameters, and the processing speed will depend on the parameters you chose when setting up your query. So these are the parameters we chose earlier. Whilst the query is processing, icsynth will display the synthesis tree as it's being generated and will automatically show the best results according to the system ratings. This is an interactive tree with each node representing a precursor. Now we see the query processing is finished and ready. You can navigate and visualize the tree using several features. The nodes are automatically assigned numbers, and the bottom scroll bar navigates across the tree. You can also resize it to zoom in and out. The plus sign under a node indicates that further steps are available and the tree can be expanded further. We now have gone back 2 steps on the synthesis tree. The hand icon collapses and expands the tree at a given level. You are now in a position to evaluate the results and decide which synthetic pathways are the best to follow through. By clicking on the node, you can see the precedent reactions and reference details. The suggested reactions are based on and linked to published reactions that were used to create the knowledge base. Here you see the suggested reaction and the precedent reactions along with their references. You can then scroll through the list and decide whether the chemistry is of relevance. If you see a reference has derived from the Sprezzi database, you can click on the link and log into the Sprezzi database to see further information about the reference. You can now view the reaction details in Sprezzi and link to the journal publisher website to view the full article if you have the appropriate license agreement. Returning to the reaction window, you can switch between Carousel View and List View. This enables you to scroll up and down the list. Returning to the tree display, you see that some nodes contain coloured squares. The green square indicates that the compound is commercially available, for example, ethyl magnesium bromide. Clicking here will take you to the Sprezzi page, where details of the commercial supplier can be found under the Supplier drop-down menu. Choose a supplier and link to its homepage to purchase the compound directly. In this case, Sigma Aldrich is selected, and we now link to their website and can view the purchase information. Going back to the tree, we see that some nodes have a blue square. This indicates grouping. The purpose is to represent a group of similar structures using one structure, thereby reducing crowding on the tree. In this case, the structures are grouped by similar substructure. Grouping can also be based on common bonds changed. Indeed, no grouping is also an option, but this may increase the size of the tree. You can also select intermediates for further processing by clicking on the asterisk underneath a node. This restarts the retrosynthetic analysis and continues the tree from that node. It will change to a plus sign when complete. We now have the plus sign in place, so the tree has been continued at that point and can expand that node to the next level and browse and evaluate the suggestions. Another way of modifying the tree is to remove unsuitable nodes. This can be done by selecting the node and clicking on the cross next to it. The tree will then be redrawn without the node and renumbered. To start a new retrosynthesis from any node on the tree, click on the tick next to the node, and that structure will become the new target. You will return to the New Query menu, where you can repeat the same procedure with the same or different parameters, and generate further steps back to your desired starting point. Going back to the tree, having evaluated the suggestions, you can then select a specific pathway for export to Excel. For example, if I wish to choose this retrosynthetic pathway, click on the box next to the node number and the pathway is highlighted in red. I can then export this into Excel. Here we see the Excel spreadsheet is ready. If we open it, we can see that it contains the target molecule, the suggested reactions, and the reaction conditions, along with the yield and citation if they are available. This is useful for your reference and record keeping. Looking at the other commands across the top menu, you can view previous queries and their history by going to Queries Open. Show will reload the tree, Rerun will rerun the query, and you can also rename or delete it. Likewise, under Assets, you can view and manage the list of saved molecules. So to sum up, icsynth is intuitive to use. Firstly, draw your target compound, select your search parameters, the default options being there to help you. Then evaluate the tree output. Further analyze the nodes on the tree, link to the literature reference. Continue the tree, or select a node as a new target for analysis. Then choose the desired pathway, then record or export the results. Thus, Infochem's icsynth can facilitate innovation by stimulating ideas for alternative or novel synthetic routes that otherwise may not have been considered. The benefits may include improved route design, shorter pathways, or more economical reaction modifications. Thank you for watching.